The development of submarine-launched unmanned aerial systems, or SLUAS, is a groundbreaking innovation in naval warfare, blending the stealth of submarines with the intelligence-gathering power of aerial drones. This technology enables submarines to conduct reconnaissance, surveillance, and communication tasks without surfacing, marking a pivotal shift in modern military operations. The United States Navy has been at the forefront of this advancement, with a key milestone being the successful deployment of the Experimental Fuel Cell Unmanned Aerial System, XFCUS, from the USS Providence, a Los Angeles-class submarine. This demonstration showcased the ability to launch a drone from a submerged submarine via a torpedo tube. The drone was housed in a special capsule, which ascended to the surface, releasing the UAV for flight. This success proved that submarines could deploy unmanned aerial vehicles without exposing their position, enhancing real-time intelligence and situational awareness. Building on this achievement, the U.S. Navy introduced the Blackwing unmanned system, a more compact and versatile platform specifically designed for submarine use. The Blackwing allows submarines to extend their visual and electronic surveillance capabilities. With this system, commanders can monitor surface activities, track threats, and share critical intelligence, all while remaining undetected beneath the waves. The implications of SLUAS technology are profound. Submarines traditionally had limited situational awareness above the surface, relying on external assets like satellites or manned reconnaissance. With SLUAS, submarines can autonomously gather intelligence, assess their surroundings, and even operate as forward nodes in integrated battle networks. This capability strengthens their role in modern naval warfare, emphasizing the importance of multi-domain operations, where assets from different environments collaborate seamlessly. In addition to military applications, SLUAS systems hold great promise in peacetime. They can be used for maritime security, monitoring illegal fishing, smuggling, and piracy activities. Their ability to operate covertly makes them especially valuable for intelligence gathering in politically sensitive areas. Furthermore, their compact design and modular payload options allow rapid adaptation to various mission needs, whether for surveillance, electronic warfare, or payload delivery. However, SLUAS development is not without its challenges. Ensuring reliable communication between a submerged platform and an aerial drone requires advanced encryption and signal processing techniques to prevent detection or interception. Additionally, creating drones capable of withstanding the pressures of underwater deployment and performing effectively in harsh conditions demands significant innovation. As technology continues to evolve, SLUAS will reshape naval operations, offering submarines enhanced capabilities for intelligence gathering, threat tracking, and multi-domain integration. The future of underwater warfare is evolving, and SLUAS technology is playing a crucial role in this transformation.